So this audience is actually the first audience that has ever seen this presentation or ever heard of this company in a public forum. So you might be in luck, or it might be boring. We'll see. But it's a company called Layer. We're kind of making fun of everything called something layer or layer something. But really, we are a layer that sort of sits at an abstraction level above and across from a lot of things. And so it's really hard to define what layer this sits at. And so that's part of the inspiration for it. But I'm going to kind of start with the why, right? I have been around in this ecosystem for a pretty long time. Since basically 2015, I helped create this company, Consensus. We funded a lot of the seminal infrastructure in the space, and at that time, people were saying, let's just decentralize. Let's kind of hand wave, right? Some guy said this circa 2015, but people were talking about doing AI agents that control DAOs, like the DAO. People were talking about how we were going to decentralize almost everything, decentralize Uber, decentralize marketplaces, whatever. But no one really thought about it too deeply as to how we would achieve that. And now, 10 years later, we're bumping up against like the real problems there. And so, but the initial thoughts about how to do this kind of assumed decentralization. Actually, the people that originally designed the internet assumed decentralization. So this guy named John Gilmore, who was a pioneer of the Web 1 era, he said the internet interprets censorship as damage and routes around it. So even these very early guys, they were naive because they didn't really anticipate that state-level actors would try to then co-opt the network infrastructure and actually control it. But they thought they were building a decentralized system. Now, in Web 3, we think we're building a decentralized system, but we haven't really done it yet. This was Mist browser. So this was the first concept of how we might actually have a decentralized front end. That kind of went away maybe 2017 or so, but there's sort of applications there. This was the original kind of thought as to how the Ethereum stack would look. It had not only the Mist browser as the front end, but the decentralized applications, Swarm for storage, Whisper for messaging, and EVM. That was how we thought this was going to look. Of course, that didn't happen. We have centralized front ends everywhere. We have centralized messaging, centralized bridges everywhere. There's a lot of basically people sort of do decentralization theater almost. And then if something's hard to do, you just don't do it. We'll decentralize it later. We'll figure it out later. Often that ends up with either lawsuits or it ends up with honeypots to hack. It's just not the true vision, right? And let's see if we can get there is kind of the point, kind of the motivation for building Layer. 2017, this is kind of just my rough mental model of things that stood out in these years. Everyone know CryptoKitties? It broke Ethereum. So also not decentralized, right? Because where is this stored, right? It's actually mostly right now stored on this thing called Pinata. I don't know if you guys are familiar with this, but all the NFTs that you have on your OpenSea account, unless it's stored on IPFS, it's probably stored on something like this, which is actually a centralized server. Just kind of an example of where we're kind of fudging it around the edges. 2019, this is about when the original architecture for OP came out, and they put their testnet out. This is the sequencer architecture for OP. So yeah, it's really great that we have this L2 architecture, we can scale things, et cetera, but turns out there's actually an AWS server sitting somewhere that's actually centralizing all the transaction sequencing, and it's a point of failure. That's fine, right? It's a step in the right direction, not to bash optimism, they're amazing, but we haven't quite done it yet. No one's really quite figured out how to have an elegant decentralized sequencer yet. Another edge case where it's not really done yet. So 2020, obviously people were working on this before, but this is when ZK first started to really get into play. And so this is a diagram of Starkware. And you can see all these nice things, sequencers, mempools, et cetera. On the right, you have provers. Pretty much all ZK provers are centralized right now. People are building on eigenlayer AVSs that are trying to build decentralized prover networks. Alio has tried to build a large incentivized decentralized proving network. Different people have done it. Mina has a decentralized proving network on it. For the most part, this is actually just AWS because it's more expensive and VCs will pay for it, and that's fine. But if we actually really want to do this, we need to also decentralize those. And that's possible even now, right? On eigenlayer, people are building it. People are building coprocessors for this. And this is what I think the ultimate architecture looks like if we're really going to realize the true vision here of a decentralized Web3 ecosystem. 2024, we're standing here right now. The front ends are still centralized. This is about how Uniswap is getting sued, or they already got sued about this. But it's sort of decentralization theater, right? If there's a central choke point, it's not truly decentralized, and that's great. You know, it's not just for avoiding things like regulatory regimes. It's for the resilience of the network. It's for realizing the true vision of what we all thought we were doing here, which is building this resilient, self-regulating system that doesn't really need any inputs. It doesn't have any central points of failure. But we haven't quite done it yet. We still have centralization at all kinds of edge points. So what does the actual end game of this look like? I think there are a few different approaches to what it could look like. And also a few different approaches to how we just scale in general. Like, how do we keep going? What are the next architectures? And I sort of deep dived this a few years ago. You know, I think Sriram laid this out pretty well as to what the various directions are. You can use ZK, where you need to pay for provers. You can use optimistic rollups, where you kind of need to wait for settlement lag. Or you can use crypto economic security, where you need to pay for capital costs during settlement lag, but it's instant, right? So these are kind of the three general categories of the directions that people are building. I personally believe, my two co-founders personally believe, that the third one and the eigenlayer-oriented one is probably the right one and the least explored one. And it enables actually the decentralization properties that we're talking about. So we started building in this direction, and we ended up with this thing called Layer. What Layer is, essentially, and it's interesting, the previous speaker mentioned a lot about sort of their path through figuring out what to do and how to build. We had a similar thought process, actually, and like there's a lot of content that I could repeat that I won't of what he said, but you know, it turns out a lot of people have gone down the same roads and tried to build the same things. But we started with where we think there's, you know, obviously the most crypto economic security right now. Maybe that would be Bitcoin, but the most accessible crypto economic security is Ethereum. I think that's why Eigenlayer is built on it. So we started with that. Eigenlayer is built on top of that, obviously. It consumes it. There are lots of applications and services to be built on top of Eigenlayer. Those things take the form of basically Docker containers right now. But there's this sort of like gap, there's this market gap in between. Like, how do you actually build those things? If all you get is an Ethereum validator that's running Eigenlayer software and like basically Docker, then what do? So you've got payments, right? Like, say you make a ZK thing that's running on Eigenlayer validators, and you want it to run well, but you want to get paid for it. Or maybe not only get paid for it, but you want to make a derivative of that, or you want to take that payment or some representation of that payment and put it in a DEX, or lend against it, or make futures about it, or whatever you want to do, some kind of DeFi thing. You can't really do that. All you got is a Docker container. And that Docker container, the Hello World example, Eigenlayer is wonderful, and we love them, but that Docker container is 20,000 lines of code just to like square two numbers, right? And you don't have a chain, you don't have a way to, to connect into anything in Web3. You can't send payments, you can't send state, you can't receive state. You're pretty much on your own. And so how do you solve those problems? A lot of people are trying to do it in kind of kludgy ways. I've seen like people sending payments on Polygon and then trying to verify that something happened on Polygon. I've seen people try to take payments on ETH-L1 for databases, and then you're paying $1 to have a database write or something, which doesn't really make any sense. So it's sort of an unexplored area of how to solve this problem. So you have all these things floating around there. Let's see. So I don't know if any of you guys have seen this video. So the solutions start to look a little bit like this video. This guy's going to try to open this van with a very kludgy set of operations, and I think this is kind of what the solutions look like so far. So, people would say like, oh, this thing kind of looks like a stack. Can you stick OP in there? No, that doesn't make any sense. Can you stick something else? Can you stick some Polygon stuff in there? Yes, you can. Some people have tried to do that. Like, it hasn't really worked that well so far. And so, what are you going to stick in there? Some people have successfully stuck Cosmos in there, and this is sort of, alluding back to the last talk. There are a bunch of problems with Cosmos. Cosmos is great. It's showed us a lot of things about how architecture should work. But it has a lot of problems, like upgrading it's very, very difficult. Maintaining it's very difficult. It's not actually modular. It's all spaghetti coded into each other, which is why it's so difficult to upgrade, et cetera. So we actually ended up building an entirely new stack as well, also with some inspiration from some of the good ideas there, like IBC protocol, for instance, is deeply integral to what we do. Tendermint's part of what we do. Ethan, one of my co-founders, he was the first employee of Tendermint. He designed a lot of it. He also was one of the authors of the IBC white paper. So some similar ideas in there. And some companies like Aligned Layer, for instance, which is a wonderful company. I know they're using the Cosmos SDK because you want something that looks like a chain that kind of sits in that market gap there, right? You want to take payments. You want to have maybe smart contracts that determine what happens after you actually produce your ZK result or your AI result. You want some rules. You want something to happen other than just a Docker container spitting stuff out on a network. But it's difficult. And so our answer to that is Layer. Layer is a full stack. You could deploy it as an L1 if you wanted to. You could deploy it as a lot of things, but it is extremely modular. It's based on WASM. It's highly performant, and it sits on top of the EigenLayer validators, and it lets you essentially deploy WASM bundles to it. So we call this an actively validated layer architecture. So our stack, you could theoretically use the stack yourselves if you want. It's sort of a drop-in replacement for a full blockchain stack. There really aren't that many of them that exist. Probably Cosmos is the only one that has high usage that exists. So you could build your own thing that is connected to EigenLayer underneath if you wanted to, and have your own entire chain. Or most people don't really want to build and maintain a whole chain. If they just want an application, or maybe at first they just want an application that has all those properties, that has payments and smart contracts, et cetera, and later they want to build a chain. And so what Layer is, what sort of our network is a chain that sits on top of EigenLayer using our own stack. But what's special about it is it lets you deploy these things called containerized AVSs to it. So essentially, WASM is very special in that it can touch a lot of different parts of the computer. It's it's worked on by probably the most engineers of any VM in the world because it's adopted in browsers, et cetera. But it has the ability to touch basically bare metal. So you can send us a completely compiled WASM bundle that wants to touch the GPU, it wants to touch the file system, it wants to touch the CPU, obviously, it wants to touch the networking system. It can do that, right? So if you want to build an Oracle, all you have to do is make networking calls, and you ship it to our chain, and it runs. If you want to make an AI inference engine, all you have to do is do your business code, compile it to WASM, send it to us. We orchestrate it on the EigenLayer validators underneath. We've already recruited all the restaked Ether. We've already recruited all the operators. Your time to market is dramatically cheaper, and all you have to think about is AI, your actual company, instead of making and building and upgrading a chain. There's some other interesting properties that you get out of that too. For instance, do you really want your distribution system of your highly secure thing that might have billions of dollars running through it being a Docker container repository or GitHub's equivalent or whatever, right? Another centralized Web 2 service. No, you'd rather have it orchestrated and managed on chain. This is, in our view, I don't know anyone else doing something like this. This is like a novel new primitive that actually lets us make full stack decentralized applications in Web 3. So now you can have a chain, you can have an AI GPU using software system, and it never has to touch any Web 2 centralization system at all. I think this actually allows us to achieve the results that we were talking about earlier. As I was saying, you can kind of create your own layer if you want. You can start as an application and then eventually use our stack. We are also a restaking protocol. We're using restaked Ethereum right now from EigenLayer, and I think that's a great way to do it. Using Ethereum as a settlement layer as well. So we do some special sauce that allows you to actually have Ethereum underneath, and you can maintain and monitor and also interact with the state of Ethereum itself. So if you want to have L1 tokens on Ethereum or behaviors on Ethereum L1 impact the behavior of what you're doing, or you want to send tokens back to Ethereum L1, you can also do that. It's sort of a novel type of bridge almost, you can think about it as. But there's not really enough time for us to go completely into the restaking of what this is, but my two co-founders also are two of the three architects of mesh security, which is what the gentleman before mentioned as the version of restaking that's in Cosmos. So Layer is also a restaking protocol. These containerized AVSs can restake to each other. They can restake to us, and they can restake to anything that speaks IBC protocol, actually. Sovereignty is obviously one of the properties that we went for. You can make a whole chain out of this using EigenLayer validators if you want. It dramatically reduces time to market, cost to market, and dramatically increases the feature set of what you can do as an AVS. And it also lets you do completely new things that you couldn't do before. For instance, you can make on-chain agents. You can make composable structures that can, say, sit on chain, run as a long-running process, run an AI process that can trigger something to happen in DeFi, et cetera, and never touches any centralized process at all. It's really kind of a new primitive that no one, even we don't know what people are going to build with yet. So that's it. Build on Layer. Follow us on Twitter. Layer on ETH. And thank you very much.